Hello everyone, I'm Gang. Okay, in this lesson, we'll continue, and now we'll talk about another OSEC. Oh, you can see it here. For this OSEC, we won't add a task, it's eval. And here you can see it's showing red. The reason it's showing red is that we need to press enter, because some things pasted in might not be entirely accurate. Then okay, so here we're using OSEC, and the declaration method for OSEC is quite different. It's declared like this. Let's first write a standard one. You'll find that it actually also starts with the first enum, but its enum is different. For this enum, we have to do it like this. Its first enum passes the exaction thing. The second one passes these. Some of these quables, retreats, type inference, some things like that. Then let me show you how we should write such a thing. Let's look at the comments first, and it says to do a step of a given method. Then there's an example here. Obviously, this places a method, right? Then here it declares a tunical function. This is actually a tfihon, similar to a function pointer. Something like that. Its return is actually this int. It has no parameters. This int corresponds to this int. This thing corresponds to this thing. Then this name is called task. Then its address points to this address. Then we have a result here. We can execute it through such a transmission. Using lambda is actually the same. You can see here. It is a tunic function. Require an intersect. Then it waits for a lambda, right? Actually, it's O2. We usually write these as O2, and that's fine. Then put it here. That's also fine. And this is an inline lambda. We like this style the most. We just write it directly here. This asset text. You'll notice there's also this return value. Then it will return a TFuture, something like that. You can get this value. This value is our filter. TPromise are very useful. That is, I execute this task, but I don't necessarily need it right away. But I also don't know when I will need it. But when I know I need it, it must be available. Otherwise, I will block it. So this is a simple function of filter and TPromise. Then we will demonstrate it for everyone later. So this is what Global is like. As for its underlying implementation, we won't look at it. Mainly, let's look at this parameter. You can select the thread it executes on. This is for short tasks. Use this TaskGraph to execute. Then this is also a short task. You just use this kind. Main thread, it's this one in the TaskGraph. The main thread executes, and this thread is very important. This means creating another one. That is, creating another thread. This thread has no relation to any other thread. Another thread is created. Then execute a long task. That's the situation we just had. That is, I create a thread. This thread needs to do 50 asynchronous tasks. Then thread number 2 manages 50 asynchronous tasks. Then all 50 of these side tasks failed. Thread goes up and mainly talks about thread 2. Then the main thread only needs to care about your thread 2. When will you tell me? The main task is done. That's fine. And here are the thread words. And here are some pseudo thread situations. Okay, then this part. See, it's actually more or less the same. After explaining it, we'll just write it in the simplest way. Selection. If you use TaskGraph, the effect is actually the same as what we wrote before. It will still mainly talk about the main thread. But if you use this straight. You see, if you use this, it won't block the thread. Then we still write the same code. Then it won't block the thread. We copy this over. We just rely on this. Rely on this straight. We still let it run for 2 seconds. We can create a for loop here. I see I have a for loop like this. Copy this for loop over here, and then delete this part here. Then put it here. The performance of this OSEC is extremely poor. Don't use OSEC. Generally, this is not used. Usually, using OSEC task is fine. Then do it like this. In fact, it won't block our main thread, but its CPU usage is very high. Okay, so because it's equivalent to here, spawning many threads, we can set a brain for it. We can actually... Wait a moment, we should have a piece of code that can read this information. This piece of code should be able to read this information. It should be here. Let's put it here. Then let's print it. Okay, then put this here. Put it here and then insert it. Because right now we are actually doing this on the main thread. Actually, there is a more solid way to do this. That is, I don't want to create this thread on the main thread. I also say doing this in to main thread is wasteful. So let's just task ending suite. Do it like this. Then drop another layer. This kind of nesting is actually a bit annoying. But once you understand it, there should be no problem. Then we let another county. For example, let our number 2 county create 100 new counties. This number 2 county is a county within the graph. Then these 100 new counties just made their own business. I don't care what they do either. Anyway, after you finish our number 2 county, then we won't bother with it. In the end, our number 2 county has not yet been registered. And here we can understand county road 3203 all go to do these tasks. Let's execute this now and then continue explaining to everyone. Okay, then we enter our level blueprint. Here we have an inmate. Async. This is also async. Let's put it here. Good. Actually, at this point, it won't block our main thread. Let's start now. You can see our main thread is completely unaffected. And you can see all 100 tasks are completed, but pay attention. You can see they all have this name. These threads are all newly created threads. They are not threads from our thread pool. If you go check now, we can't set breakpoints now either. That means this part is actually gone. These threads may not be reclaimed immediately. Anyway, after a while, they'll just disappear. They get reclaimed on their own. That's roughly what it means. Then let's set up a tick to show everyone. There should be a scene tick here. Let's bring it in and take a look. Okay, you can see this tot, right? Right now, it's like this. Now it's like this. Let's move it over. Let's be quick. At this point, press 1. Let's be quick. Let's interrupt like this. Let's see if we caught up. Check if he is finished executing. He has already finished executing. Then let's give a little more time. Let's make it sleep. We wrote here, we need to sleep for 10 seconds. Oh, let's go take a look now, whether he actually created these threads. Okay, then let's just click it first. For this general tick, let's first disable this breakpoint. Then press 1. It has started executing now. Let's check the tick. Hey, we're in now. You can see. Hey, do you see it? Right. Let's come in again later. It's gone. Let's die. Let's count down 10 seconds. Actually, it's already gone now. Let's come in again. So this thing is really fun. At this point, you can use these things to do some fancy operations. Often, it's because there's no other choice. Sometimes, you really want to design a set for the project, a very smooth one-step framework. Doing it all from scratch, by yourself, is the best. But you don't have that much time. They might need it in a couple of days. This Friday. The client said this Friday. It needs to go live this Friday. You guys immediately load this multi-threaded layer. Optimize this thing for us. And we need to see the results right away. And spare no expense. Spare no resources. Then we'll just do it like this. Doing it this way is completely fine. No problem at all. But you know the correct design shouldn't be done this way. And you shouldn't deploy 100 tasks all at once. You might need to download them in batches. Because I have worked on this multi-threaded download feature before. So I need to emphasize this detail here. Okay, then let's continue with the next topic. We haven't finished discussing SX yet. The most powerful feature of SX is that it can obtain a future value. So how does it do that? Let's switch to this. We call it getter far the future. This part is actually somewhat similar to C++. We can search for it. Similarly, we can block the main thread, or we cannot block the main thread. In this case, it is clearly not blocking. We do not block the main thread. We follow the standard approach. So here, the previous code from Xiaomi means after it finishes executing. Let's change the time to 2 seconds. For this time, we can let it run randomly. Let's see if there is a random time option. Let's check math. It should be there. Run it. Let's see if we can pass a parameter to generate a random time. This is a random seed. Wait, let me find it. Sometimes it's really not easy to find. Sometimes searching for it can be quite exhausting. We search for this random and find it. Indeed, it is in this Kismet database. Let's just create a random directly. Obviously, it is not included in that location. Right, let's take a look. Its path should be. Let's switch to the head view to see. Kismet's data is stored under Kismet. It is undergone class. So we directly from here include Kismet. Okay, good. Now let's come back. That this seed of ours is Radobain, Bondomenk, Flotondomenk. Okay, that's it. Let's make it random. Random 5. Don't take too long either. So the time is actually not very certain. Intersense sleep time. Sometimes we, in order to preserve some optimization space for the client, you can just sleep, right? This is a programmer's inside joke. Then here actually after it finishes executing here, we'll log a message here. Execution complete. Actually, here it's just, what should we call it? Call it task construction complete. Task construction complete. So when is it actually fully executed? This is more complicated. So we need to declare one here. Here we need to give it a return value. We return it. Return what? Return its time. Intersense 2. Then here we return it. I want to return a time. What if I want to return multiple values? Then just make a struct. That's fine too. Then here we are. We need to declare something like it's a future. The host should be like this. It should look like this. So this is a return value. So here, feature result. Then we take this number. First, add a default one. Add default. Then we get this default one. Let it equal the reference we got from the default. As long as it equals this, it's fine, because it has a return value. You can see its return value is of this type. Okay, so what it actually means is these 100 tasks, after each task is executed, they will all put the results into this array. So, to ensure that the tasks here are completed, I definitely need a task here. All tasks are executed. I definitely need something that indicates all tasks have been executed. Something like that. Okay, then we can do a for loop traversal here. Just let him give it to him. Hey, you see this TFuture, this is it. That is, it means you get a future object. And at the same time, there is actually a promise. See TPromise. Promise should be this. It is. You see this right here, TPromise. And note that when you use TFuture and promise, you need to manage them properly. Otherwise, it may cause some errors. That is, when you execute, when you close the program, or when you start it. If you don't correctly handle this promise or future, and only perform a sudden termination, because the engine will check the TPromise. I have used TPromise before. I found that if you don't correctly set or release the promise value, it will, when the engine shuts down, give you a breakpoint or an error. And here we use a negative loop to let it get like this. We can just use outtube. We can use this reference TMP future to iterate over this. And here we can actually, we can't get any more information here. We just let it get. This method will block if it hasn't been completed. It will just keep waiting there. That's the general idea. So this is quite interesting. Then after it has retrieved everything, the return value of this get is actually an int312, which is the slide time of this task. Actually, we can print it out, or we can choose not to print it out. Either way, it doesn't matter. So let's print it out. We'll just print it directly. Here we call it fstream. I should have mentioned this to everyone earlier. See, all the information is connected here. Okay, so this task means that our main thread spawns a new thread. This thread, what thread is it attached to? We don't care. So this thread will execute 100 tasks. After all 100 tasks are completed, it will then report the result. So actually at this point, you can remove it. Once all tasks are done, you can pass the task information to the main thread. How to pass? Games week, we are working on silver days. There, we didn't directly pass it. Look at this place. We can consider this place is at 50% progress, right? Then this place might be at 100% progress. Then call the main thread to execute subsequent operations. Yeah. You might think this place isn't practical enough yet. Actually, we are about to get into practice because we're almost done covering these basics. Okay, now let's try another method. Let me see what this method is called. It's called getFuture, AsyncFuture. Okay, we can take a look. Now let's execute it. Then observe our log. We can bring up the CPU resources to show everyone. Let's see if we can capture the screen. Doesn't seem to work. Let's just ignore it. I'll just execute it directly like this. It seems like we can't really see the result. You see, here all tasks have been constructed, but they haven't finished executing yet. You see, where is this so-called log printed from? Let's take a look here. Is there something wrong somewhere? Maybe 2 seconds is too long. Let's check again. Actually, you see, this part is correct. Let's take another look. So you see, it was like this at the beginning. That is, you start building the task here, then the first task. You see, this thread is built and executed like this. Then all tasks are built. That is, the build is complete. All tasks have been built. Then you will find that actually, it constructed this time relatively late. You can see. And here, we start to get this value. After getting this value, here we get all the values. Then all tasks are constructed. That's roughly the situation. Let's check. Why are all these times 0? I took a look. The reason they are all 0 should be an error. We shouldn't do it this way. Let's just include the I in the calculation. Then let's make this time. Let it take the remainder. Yes, let it take the remainder. This is because sometimes when you run, it's a randomness issue. That is, you'll find that sometimes the random results are the same because its underlying pseudo random generator is a weak random. Let's set it to modulo 5. This 5 takes the remainder. Okay, then this time should be normal now. Let's fix this time. Because of the run function, let's change the state as well. Let's have it complete all task construction. All tasks have been built. All tasks here have been executed. Let's take another look. Okay, now let's observe our log while executing. You can take a look, right? You will notice. Yes, does it achieve the expected result? All tasks have been executed, right? It can be seen. So we need to scroll back. All tasks have been built. This is just the build being completed. After building, they execution complete. Then we actually achieve this effect. That is, we created 100 counties through one county. They executed 100 tasks. Finally, these 100 tasks, I tell county number 2 that it's done. County number 1 and number 2 finished. Tell county number 1 it's done. All tasks executed. That's roughly the operation. Very complicated. Still quite complicated. Everyone please understand. Then what we are about to cover is probably all of this And actually, there is another kind. There are also many other situations. For example, some are order dependent. That is, its test graph can actually establish this kind of sequential dependency relationship. If we have time later, we will explain it to you. We need to get into the practical part as soon as possible. We will also cover country flow, because country flow is very useful. It should solve our initialization flow problem. Alright, we'll stop here for this lesson. Thank you everyone.